Good afternoon, dear students. Welcome to another session on Introduction to Data Structures and Algorithms. Today in Module 5, we are going to introduce the very important data structure, that is graph data structure. So, I have given assignment 8, so which you have to submit before 5 p.m. on 22nd July. Okay, this is a small announcement. When we talk about graphs, graph is one of the very important data structure. Till now, we have learned about different data structures such as arrays, linked lists, trees, etc. In this chapter, we will learn about another important data structure called graph. It is very similar to mathematical graph structure, which comprises of a set of vertices connected with each other, and we call it as the edges. Some of the typical operations performed on graph data structure including finding the best possible path between two nodes, finding the total cost of the path, the shortest path of the shortest cost path, and of course data structure finds its application in a variety of domains, especially in computer networks and network analysis, travel applications, microprocessor chip design, gaming, you name anything. So graph data structure, it is very much used. In this chapter, we will discuss about all these concepts which are very, very essential for your career. Okay, basically, graph is nothing but it's a set of vertices and edges. In the previous slide, we have discussed the nodes are called vertices and the interconnecting lines between the vertices are, we call it as edges. And a graph, we call it as a collection of nodes, that is vertices and edges. So we certainly write them as g of v comma e mathematically, where v is a set of vertices, starts from v1 to vn. Same way, e is a set of edges, it is starting from e1 to en. So in this graph, we are seeing the edges that are not given any direction. That's why this graph, you call it as undirected graph. It is called undirected graph. And of course, some graphs, you will also have the arrows, which you call it as a directed graph, or it is also called a digraph. And of course, for digraph, you will have two sets, that is v of g, it's a set of vertices which talks about v1, v2, v3, v4, v5, the vertices that are involved in a directed graph. Look at this diagram. I'm talking about in the context of this diagram. And this is undirected graph. Figure 7.1 is undirected graph. 7.2 is a directed graph. Here, E of G, the edges of the graph G, includes what are all the edges that are given unidirectional, one direction. V1 to V2, there is a link V1 to V2. So you just write them. Look at here, V1 to V2. That is what you call it as E1, edge 1. E1, you certainly write it here. And next, V2 to V3. Next, this is V2 to V3. V1 to V4. Yes, V1 to V4. And V4 to V3, yes, this is, and V5, V3 to V5, this. So all the edges that are having a direction, we have written as set of edges. So here edges of the graph is nothing but you will write the two vertices, because one is the starting, another one is the ending point. V1 is the starting point. Look at here. V1, from V1, this edge E1 is a starting, and it goes up to V2. It goes up to V2. So that is the concept. And apart from this, we also discuss about some of the terminologies that are used in graph. The first one is adjacent node. Adjacent node is nothing but the node which is having direct connection. We call it as adjacent node. For example, if you take what are the adjacent node of B, it is nothing but A is adjacent node, because B to A there is a direct link. B to C there is a direct link. So this is also an adjacent node, and B to D it's an adjacent node, where E is not the adjacent node of B because there is no direct link. So that is what you should understand. That is what you should understand. So you should understand all these terminologies. Okay, next, in a directed graph, if you look at the directed graph, predecessor is nothing but, look at the previous example. The line is going, the edge is going from V1 to V2. So V1 is a predecessor, V1 is a predecessor, and V2 is a successor. So this is a predecessor. I can write it as V1 as a predecessor, and this is a successor, successor, successor. This is a successor. So that is what you should understand. Predecessor is a node that represents the directed edge from U to V, where U is the predecessor, and successor, that is which you call it as U to V, V is a successor. V is a successor that you have to understand. V is a successor that you have to understand. P is a U is a predecessor. Next, when we talk about further terminologies, degree. Degree is nothing but the number of edges that are connected to a vertex. We call it as degree. In that, suppose here, if you look at this particular, F, there are 2 degrees. 1, 2. Two lines are connected, so it's 2 degrees. It has 2 degrees. And E, if you look at 3 lines are connecting, 3 degrees. And C, if you look at 1, 2, 3, 3 degrees. And B, if you look at A, from A to B there is a link, B to E is there is a link, and B to C there is a link. Okay, it's a 3 degree. It's 3 degree. So that is what you call it as degree. And in degree is nothing but the incoming arrows, we call it as in degree. It's in a directed graph, the in degree of a vertex is the number of edges that is ending at that vertex. If you look at B, the in degree is 1 and 2. That's why it is written in red. You can see it is in degrees 2. For the C, 2 edges are coming from B, and from A 2 edges are coming. That's why it is 2. If you look at D, one is coming this side, another is going that side. So one in degree, one out degree. Out degree is the edge which is beginning and going out, out degree. So in this particular example, we can see the in degree and out degree. Okay, in degree we have written in red color, and out degree we have written in blue color. So that is what you should understand. Next, what is a path? Path is nothing but it's a sequence of vertices from one vertex to another vertex. So definitely, if you want to reach from V1 to V5, so what are all the nodes that you have to cross? What are the vertices that you have to cross? The entire sequence, you call it as the path. Of course, you can see from V1, if I want to reach V5, so I have to go to V1 to V2. So this is one path. From V2 to V3, I have to go. From V3, I have to go to V5. This is one path. Okay. So that is path. Cycle is nothing but it is also a path where it starts and it ends at the same point. For example, look at here. I will start from A, I go to B, from B to D, I go, from D to E, I go, from E to C, I go, from C to A, I will come back again. So this is what you call it as a cycle. Cycle is nothing but the same thing. Cycle is the same. Cycle is where your starting point and ending point are all same. Next, loop. Loop where starting and ending points are same. Starting and ending points are same. Look at here. Here, you look at here. C. From C, I travel. Again, I reach C only. This is a loop. You can see this is a loop. This is a multiple loop. From A, I start one way and I reach. Another way is there. That is also same. You start from one node, you will reach the same node in the other end also. So it is an edge whose endpoints are same. So if the path is same, then it is a cycle. If you look at edge, if both the points are same, then starting point and ending point both are same, then it is a loop. In a path, if starting point and ending point are same, then that is called a cycle. That is the two difference that you have to understand. Next, weighted graph. Weighted graph is a graph in which each edge is given a weight, is given a value, numerical value. So that is weighted graph. Look at here. The first diagram which I am showing is a weighted graph. And next, connected graph. Connected graph is a undirectional graph in which there is a path between each pair of nodes. So from this node to this node, there is a path. From this node, there is a path. This node to this node, there is a path. This node to this node, there is a path. From this node to this node, there is a path. Okay, there is a path. Path you can reach. So there is strongly connected. Next, so strongly connected is a directed graph in which there is a route between each pair. There is a route between each pair. So look at here, from A to B, there is a route. From B to C, there is a route. From C to D, there is a route. And C to A, there is a route. So this is what you call it as strongly connected pairs. So strongly connected graph. And of course, next we have a complete graph. Complete graph is an undirected graph, which is the direct edge between each pair. There is a direct edge between each pair. So here there are two endpoints. So endpoints has a direct line. Here three endpoints are from this endpoint to this endpoint. There is a line. From this endpoint to this endpoint, there is a line. This endpoint to this endpoint, there is a line. So every station, every vertex is interconnected. That is what you call it as complete graph. Is what you call it as complete graph. And next is a tree. Tree is nothing but it's a connected graph that do not have any cycles. It's a connected graph. No cycle. There is no cycle. Cycle in the sense there is no interconnection. You cannot loop it. You cannot come back to the same edge. You cannot come back to the same node. You cannot come back to the same vertex. So that is what you call it as a tree. And that's all for today's class. In the next class, we're going to discuss about this graph implementation. Next class, we're going to implement the graph implementation. Thank you for your active participation. All the class recordings are available in this particular website. Have a wonderful day.